Hi guys, today we are going to finish off the first exercise of the chapter that we already started in our last video. The name of the chapter is Surface Area and Volume. So we are done with the 4 questions of the first exercise, and we will be doing the rest of the questions today. We will finish off the exercise. And for the new faces, if you don't know me, my name is Kong and this is Posh Coaching Classes. So let's get started, guys. Alright guys, so if we go to the question number 5 of your textual book, what does it say? It says a hemispherical depression is cut out from one face of a cubical wooden block. So what are we having? We are having a cubical block. So let us go ahead and try this one. So we have a cubical block. Let me try and make this cubical block here. So this is the cubical block what we are talking about, and now in this cubical block, what is there? It says a hemispherical depression. So we have a hemispherical depression in this cubical block. It goes like this, somewhat like this. So we are digging and we have cut it out. Now what does it say? It says the diameter, okay, so that the diameter of the hemisphere is equal to the edge of the cube. So what do we have? We have the edge of the cube, which is equal to L, and even the diameter of hemisphere, which is L. So if the diameter is given, obviously we will get into the radius. So radius of hemisphere, it will be L upon 2. Obviously because radius is half of diameter. Now what else it says? Determine the surface area of the remaining solid. So if we cut this portion out, so what happens? We need to get few things. So what are we actually looking here? We are looking at total surface area, which will be equal to surface area of cube. Then we will get the surface area of hemisphere, and we will deduct this particular circle from this particular thing. So we will deduct the area of circle because we are cutting it out. So now let us see, surface area of cube is obviously 6L square. Then we have surface area of hemisphere, that is surface area of hemisphere 2 pi r square, and then area of circle obviously pi r square. So what are we going to do? We will keep it as it is, and 2 pi r square minus pi r square will be pi r square. Now what best we can do is 6L square will be as it is, pi will be as it is, but r, that is the radius of hemisphere, that is L upon 2. So we will put here L upon 2 whole square. Now what happens? It is 6L square plus pi L square upon 4. Now one more thing we can do is we can take L square out, and we will have 6 plus pi upon 4. If we further go ahead and solve it, it will be 24 plus pi. So that is the total surface area what we were looking for. So that's what was asked. It was saying determine the surface area of the remaining solid. So that is the surface area of the remaining solid, 1 upon 4, or you can say L square, 24 plus pi upon 4. That is the answer. Is that clear? Perfect, guys. So let's move to the next question, and I'll just rub this off. Right guys, so question number 6, what does it say? It says a medicine capsule is in the shape of a cylinder. So we must have seen, everybody, the capsule, the shape of the capsule. So first of all, let me write question number 6. So the capsule is somewhat like this. You must have noticed the capsule. I'm making it a little bigger so that we will have the fair idea. Okay, so this is the capsule. Now what does it say? Is in the shape of a cylinder with 2 hemispheres stuck to each of its ends. So we have 2 hemispheres. So let this be first hemisphere and this be the second hemisphere. Okay. Now what does it say? it says the length of the entire capsule is 14 mm. So this is 14 mm. Okay, and the diameter of the capsule is 5 centimeter. So this is this 5 centimeter? It is again millimeter. 5 millimeter. Find the surface area, use pi, that is 22 upon 7. So this is what is given. So first of all, let us write the total length of cylinder, which is equal to 14 mm. Diameter of hemisphere is 5 mm. So what will be the radius? Obviously it will be 5 upon 2 mm. So if I take this as the center, this will be 5 upon 2 mm and this will be 5 upon 2 mm. Why? Because radius, it is from the center and hemisphere is spherical, so we have the radius here. So radius is 5 upon 2 mm. Now what it says find the surface area. So for this we have to find the surface area of the capsule. So for this, what we are going to do, first of all, I'll take one more thing. I'll get the height of the cylinder as well. So height of the cylinder, because it will be needed, height of the cylinder. Now the actual height or the length of the cylinder is, the complete thing is 14 mm. So what are we going to do here? I'll write it as capsule. Now height of the cylinder will be 14 mm. Then we have to deduct this part, because this will be 5 upon 2 and even this will be 5 upon 2. So we are adding 5 upon 2 plus 5 upon 2. What do we have? Now we have 14 mm minus, if we take this, this will be 5 plus 5, that is 14 minus 10 upon 2. Let's take the LCM, 28 minus 10. What does this become? It becomes 18 upon 2 mm. We'll cut this off, it will be 9 mm. So the height of the cylinder is 9 mm, guys. Now what are we going to do? We have to find the surface area, and we have to make sure that the pi is 22 upon 7. So surface area of the capsule will be surface area of hemisphere, then surface area of cylinder, and again surface area of hemisphere. Right? So here we have two hemispheres, identical hemispheres. So we will put the formulas first. So surface area of hemisphere is 2 pi r square. Then surface area of sphere is 2 pi, cylinder is 2 pi r h. Surface area of hemisphere 2 pi r square. So this is 2 plus 2, that is 4 pi r square plus 2 pi r h. Now what I can do, I can take pi, 2 pi r common. So what is left? It is 2. Pi is anyways out. We have 2 r's here, so 1 r will be in. 2 is out, pi is out, r is out, h is there. Now the question itself says that you need to take 22 upon 7, the value of pi. Do we have the value of r? Obviously that is 5 upon 2. Then 2 into r is 5 upon 2 plus height of this is 9. So now can we cancel? Yes, we can cancel this, we can cancel this as well. Now what do we have? We have 22 into 5, that is 110 upon 7. Then here we have 5 plus 9, that is 14. 7 more 2, 14. So 110 into 2 is 220 millimeter square. That is your answer. Clear, guys? So this is the capsule, and this capsule, it had 2 hemispheres and 1 cylinder. We used the formulas for the hemisphere and the cylinder and got the answer. So this finishes question number 6, guys. Let us quickly move on to question number 7. You can make a note of this. This is an important question, guys. Okay guys, so let's move on to question number 7. It says a tent is in the shape of a cylinder surmounted by a conical top. So we have a cylinder, question number 7. We have a cylinder and then it is surmounted by a conical top. So this is the conical top and then this is the cylinder which we are talking about. Okay, now what else is given? If the height and the diameter of the cylinder part is 2.1 meter and 4 meter respectively. So height is 2.1 meter and the diameter is 4 meters. Okay, now what else? And the slant height of the top is 2.8 meters. This is the slant height, so 2.8 meter. Even this will be 2.8 meter. And what else? Find the area of the canvas used for making the tent. So that we will see later. So first of all, this is the actual thing given. Now what we have to do is we have to find the surface area of the complete thing. Is this a toy? It's a tent. So we have to find the area of the tent. So first let us see diameter of cylinder is 4 meter. Therefore radius will be 4 upon 2 meter, that is 2 meter. Okay, what else is given? Height of cylinder is 2.1 meter. Even height, slant height of the cone is 2.8 meters. So surface area of the tent, what it will be? It will be surface area of cylinder plus surface area of cone, because we have two things, right? So surface area of cylinder 2 pi r h, surface area of cone pi r l. Do we have do we have the value of pi given? Yes, it says you have to use 22 upon 7. So first of all, let me take pi and r out. So pi and r are out. So what do we have? 2h. Then we have pi and r out. So l. Pi 22 upon 7. R, we got the value of r, that is 2. Then is 2. Height, we have the height of this, that is 2.1 plus l. We have l as 2.8. Right guys? So now this becomes 44 upon 7. Then we have 2 into 21 upon 10. I'm taking the point out of picture. This is 28 upon 10. Now it is 44 upon 7. It becomes 42 upon 10 plus 28 upon 10. 44 upon 7. Take the LCM, that is 10. That is 42 plus 28. Now what do we have? We have 44 upon 7. 42 plus 28, 10, 7. So we have 70 upon 10. This and this goes, this and this even goes. So we have 44. And is this into meter? Yes, meter square. So this is half of the question, guys. So this is the surface area of tent. Now we are done with surface area of tent. Now it says something more in the question. It says find the area of the canvas used for making the tent. So we have to find the area of the canvas. We'll also find, that is here, also find the cost of the canvas of the tent at a rate of rupees 500 per meter square. So now what does it say? It says cost of 1 meter square of canvas is rupees 500. Now therefore cost of 44 meter square of canvas will be 44 into 500. that is 0,020. So that is the cost. Rupees 22,000 is the cost of the canvas. Is that clear, guys? Very simple. You should know the formula, you should know how to make the figure, and this is done. So this is again one more important question. Please make a note of this. I will move to question number 8, guys. Right, guys, so let's move to question number 8. It says, from a solid cylinder whose height is 2.4 centimeter. So this is question number 8. So we have a cylinder. So let's make a cylinder here. So this is the shape of the cylinder. Now what are we trying to do here? Of whose height is 2.4 meters. So the height of the cylinder is 2.4 meters. Now, and the diameter 1.4 centimeter. Okay, so this is centimeter and 1.4 centimeter. Now, a conical cavity of the same height and same diameter is hollowed out. So what we are doing, we are just taking this particular cone out of this cylinder. Even the height and the diameter will be same for the cone. Okay, that's fine. Find the total surface area of the remaining solid to the nearest centimeter square and use pi 22/7. Okay, so let us see what is given. First of all, height of the cylinder. What is that? That is 2.4 centimeter. Then we have diameter of cylinder, which is 1.4 centimeter. Radius will be 1.4/2 centimeter. Now we are talking about the cone as well. So height of the cone is exactly the same as the height of the cylinder, so that is 2.4 centimeter, and even the diameter of cone is same, 1.4 centimeter. Therefore radius is 1.4/2. If we divide 1.4 by 2, it is 0.7. So this is 0.7 centimeter. Even this is 0.7 centimeter. Now, what are we talking about? We are talking about surface area of the remaining solid. So what are we doing here? First of all, we will take surface area of cylinder. We will add surface area of cone, and so now for the surface area of cone, the formula is pi r L. So we have the height, but we don't have the L. So let us first try and find the L part. So here, what I'm going to do, this is 0.7, guys. This is 2.4. So let me get this L using Pythagoras theorem. So we will say, we know that L square is equal to 0.7 square plus 2.4 square. L square will be, if we multiply 0.7 with the 0.7, give me a second, guys, so it is 49, just a second, okay. So it is 0.49 plus 2.4 multiplied by 2.4, that is 5.76. L is equal to, let's put a square here itself, and then 5.76 plus 0.49 is 6.25. L is under root 6.25, so L is under root 625 upon 100, then L is under root 625 upon under root 100. L is equal to, we know 25 multiplied by 25 is 625 and 10 multiplied by 10 is 100. Take off the squares and the root. 25 upon 10, which means L is 2.5 centimeter. Right guys, so we have the value of L. Now we can put the values. So we have got the value of L. Now let's go ahead and find this. What does it say? It says surface area of cylinder, that is 2 pi r h. Surface area of cone, that is pi r l. And area of sphere, that is pi r square. Now, can we take something common here? Yes, we have pi. Let's take pi out. Even we have r. So we'll take r out as well. So that is 2 pi and r out h. Pi and r out L, pi and 1 r is also r. So the pi is 22 upon 7, r is 7 upon 10, twice h. What is the value of h? That is 2.4. Let's take 24 upon 10. Then we have L. L we just gone, that is 2.5. Let's take 25 upon 10. And r, just the r, that is 0.7, that is 7 upon 10. Now, this 7 and 7 is gone, so we have 22 upon 10. This becomes 48 upon 10 plus 25 upon 10 plus 7 upon 10. Now 22 upon 10, this is the LCM 10 here, 48 plus 25 plus 7. So if we add 48, 25 and 7, 48, 25 and 7, we get 80. So that is 22 upon 10 into 80 upon 10, and then this is gone. This is 2 is 16, 2 is 17. So let me write it here as 176 upon 10. That is 17.66, but it was saying nearest digit, so that will be 18 centimeters. Okay guys, so this is the question and a very good one. So you need to know the formulas, put the formulas, get the value of L. That is the main part. Get the value of L, you will get the answer. This finishes our second last question, and now we are on to the last question. Please make a note of this. We'll move to the next one. Okay guys, so question number 9 and the last question of this particular exercise, it says a wooden article is made by scooping out a hemisphere from each end of a solid cylinder. So first of all, we have a solid cylinder. So let's make the cylinder, so let the cylinder be like this. Okay. Now we are making hemispheres here and here. Okay guys, if the height of the cylinder is 10 centimeter, so we have the height given as 10 centimeter, and the base radius, we have the radius here, it is equal to 3.5 centimeter. Find the total surface area of the article. So first of all, height of cylinder is 10 centimeter. Radius of cylinder is again 3.5 centimeter. So we have one more thing here. We have the hemispheres and two hemispheres, by the way. So the radius of hemisphere will be obviously again 3.5 centimeter, because the hemisphere is scooped out of it, so obviously it will be same. So what are we trying to find? We are trying to find total surface area. Total surface area, it will be surface area of cylinder plus twice the surface area of hemisphere, because we have two hemispheres. That's the reason I have put it twice here. Surface area of cylinder is 2 pi r h, and twice surface area of hemisphere, that is 2 pi r square. Okay, so it becomes 2 pi r h plus 4 pi r square. Let's see if we can take things common, that is pi, even the 2 and r. So now what do we have? 2 is out, pi is out, r is out, h plus 2 r. 2, 22 upon 7, yes, we can take pi as 22 upon 7. Radius is 3.5, so let's take 35 upon 10. Height is 10 plus twice, r is 3.5, that is 35 upon 10. 7, 5, okay, 5, 2, 2 gone, so we have 22, and here what do we have? 10 plus, this is 2, 5, 5, 1, 5, 7, that is 10 plus 7, that is 22 into 17, 34, 17, 35, 374 centimeters square. That is the answer, guys. So this finishes another question, that is question number 9. A very simple question. There was a cylinder given, and then we scooped out 2 hemispheres out of it, and we have to get the surface area of the total surface area of the particular article. So we got the value of surface area of cylinder, we put the surface area of hemisphere, and then rest is the calculation. Very simple calculation, guys. So that was it, guys, for today. We have finished this particular exercise. We will be continuing this particular chapter in the next videos as well. We will finish off the next exercises as well very soon before your exams, and until then, please practice them, and please do subscribe to Posh Coaching Classes on YouTube, and you can follow me on Instagram as well. You have a wonderful time. Take care.